3.3 is polynomial identities, okay? On this front side of the page, we have 4 identities that we're looking at, some of which are shortcuts that you can use, you can not use, okay? Some of them are formulas or shortcuts that you're going to need, okay? For instance, difference of squares, okay? Difference of squares is something you remember from Algebra 1, or maybe you don't, but I've reviewed it this year with you, okay? We've done some factoring, difference of squares, where it's 2 perfect squares subtracted. We've talked about factoring that, okay? So we're going to look at that. Square of a sum. This is one that I think is more of a shortcut than a necessity. Some people like the shortcut. Some people would just rather FOIL it out normally or factor it normally. Okay, so we'll talk about that one. Difference of cubes and sum of cubes. These two are new. And they are new ones that you're going to have to know. Okay, they're ones that we use a little bit in Algebra 2. But they're also ones, for those of you that go farther, that stick with us in pre-calc and calc, where they randomly come back up, okay? My pre-calc and calc students get annoyed when they come back up because they never quite remember them very well. So then we have to review them, but they do come back up. So we'll talk about those on the bottom section here. Now, on this top 2, using polynomials to multiply. This is one of the topics they taught in the book. I'm going to say, these are shortcuts if you want to use them. If you know them and learn them and understand them, they're decent shortcuts. Otherwise, they're going to make it, they're not going to make it any shorter for you. Does that make sense? So I'm going to go through them, but I'll also give you the option to just multiply them out normally. So this first example A, 2x squared plus y cubed, quantity squared. Well, which identity from up above does it look like? This is not cubes, but square of a sum when you have a parenthesis squared. And so the idea here is, rather than multiplying this out, you could just fill in the formula. And that's what I'm going to demonstrate here. So I'm going to set this up. Notice it's of the form a plus b, quantity squared is what they give us. And if you follow the formula, it's a squared plus 2ab plus b squared. All you have to know to do this is what is your a and what is your b. What's in the position of a? Not just 2. It's the whole thing. It's this whole little term right there. And so in the position of A is 2x squared. What's in the position of B? Y cubed. Okay, it's that whole piece right there. Now, what I'm suggesting here is that you can just fill in this formula. Every place you see an A, you put in a 2x squared. Every place you see a y, you put in a, every place you see a b, you put in a y cubed. So let's try it. A squared. What am I putting in for a squared? 2x squared, quantity squared then, right? Because in for a is 2x squared, and then we're going to square it. What do you get when it's 2x squared and then quantity squared? What does that become?
So 2 answers.
What is 2x squared times 2x squared? 4x to the fourth? You're squaring the whole thing in there, right? Then it's going to be plus 2 times a, which is 2x squared, times b, which is y cubed. What is 2 times 2x squared times y cubed? 4x squared, y cubed. plus b squared. So you're doing y cubed quantity squared. What is y cubed when you square it?
Y to the power 6.
Y to the 6th.
How are you supposed to add it?
If it is, so there's a difference between this and this. If it's y to some power times y to some power, keep the base the same and add the exponents. If it's a base with a power raised to a power, then you multiply. Notice that's the same expression written two different ways, isn't it? Okay, so if both bases are there, you are adding. But power raised to power, you are multiplying. Okay? Question?
Yeah. What do we do with the a plus b squared at the front before the equal sign?
Are you talking about this right here? That was just like what the original problem was. I was just trying to put that under there to help you realize, like, that's the setup. Okay? So, all of that to say, if you can become familiar with this setup, and it's one of those things. The more you're in math, can you do that? Yes. Okay? You can just look at that and realize, okay, I square the first one, I square the last one, it's 2 times the first and the last. Okay? It's one of those things you can learn and become familiar with. Now, do you have to use this identity to do this? No. Can we go back to what would we have done before today?
Just splitting it and making it 2 different colors.
We'd make it 2 different parentheses and we would FOIL, yes? Does that still work?
Yeah.
Yes. Let me show you real quick. Okay, so I'm going to say or, because here's my thing. I just want you to be able to do this problem. Okay? I'm just giving you an option. If you don't like my option, I don't care. Fair enough? Okay, so the or option here is that I could have said, okay, well, this is 2x squared plus y cubed. You know what? I'm going to just put this down on the. This is 2x squared plus y cubed times 2x squared plus y cubed. You can just FOIL that out. Okay? So, as in, 2x squared times 2x squared is 4x to the 4th. 2x squared times y cubed is 2x squared y cubed. Inside, y cubed times 2x squared, another 2x squared y cubed. And lastly, y cubed times y cubed, y to the 6th. Does that match up with what we have up above?
Yes.
Yeah. You add your middle terms, and then it matches up with up above. Okay? And I just didn't leave myself a really good spot. I guess I'll do it like this. 4x to the 4th plus 4x squared y to the 3rd plus y to the 6th. Okay? The point is it works either way. Am I going to be offended if you go back and FOIL? No. Okay? Okay. Let's look at B. Which one does B match up with? B is the difference of squares, yes? The idea that this is in the form of A plus b times a minus b. If this is in the form a plus b times a minus b, what is it going to be equal to? A squared minus b squared. Now, this one's a little bit more easier to use, I think. Identify your a and b, and you're just squaring them and subtracting them, right? You don't have to worry about actually FOILing them out. What would you say a is? Okay. A is 3x squared, and what is b? 5y cubed. So the idea is, my formula says a squared. Well, what is a? We just said a was 3x squared, so it would be 3x squared quantity squared. What is 3x squared when you square it? 9x to the fourth. Minus b squared. So we just said that b was 5y cubed, and then we're going to square it. So if we square this here, 5y to the third quantity squared is going to become 25, y to the sixth. Power raised to a power, we multiply the powers. Okay? If you preferred, could you have just FOILed? Yeah, that's the point. Is that if you don't recognize the form, there's nothing wrong with FOILing still. Okay? And I'm just going to put it up here real quick to prove to you it's the same answer. So, or we could have done 3x squared plus 5y cubed times 3x squared minus 5y cubed. Well, FOIL with me. 3x squared times 3x squared is 9x to the fourth. 3x squared times minus 5y cubed.
15x.
Minus 15x squared y cubed. Insides, 5y cubed times 3x squared. Plus 15x squared y cubed, and positive 5y cubed times negative 5y cubed. Negative 25y to the sixth. What happens? My middle terms cancel, right? And so you're left with 9x to the fourth minus 25y to the sixth. That's probably more of a shortcut that you would maybe use. You have to be aware. It's a shortcut I see people try to use when you can only use it when your signs are opposite. Okay? If the signs aren't opposite, you can't use that shortcut. You have to use this shortcut. Okay. Take it or leave it for multiplying. Now, the factoring is not so much a take it or leave it. The factoring you kind of have to know. So, let's go talk about factoring. We have 4 different examples that kind of match up with several of the pieces up above. It says to use polynomial identities to factor the expressions. Our first expression is 9m to the fourth minus 25n to the sixth. Now, you have to know what form this is in. I see subtraction sign, yes. I see 2 terms being subtracted. So I'm going with it's either difference of squares or difference of cubes, right? It's one of those. The key is, as you look at the example A, Are they perfect squares or are they perfect cubes? So 9m to the 4th and 25m to the 6th. Are those values you can take the square roots of or the cube roots of?
Square root.
Those are perfect squares, aren't they? Okay, so that means that this is the difference of squares. I'm trying to think how I want to set this up. Okay. Let's start with the idea of thinking about what are the square roots. What's the square root of 9m to the 4th? Are you with them? The square root of 9 is 3, yes?
Yeah.
Remember when you do the square root of an exponent, you're just having it. Okay, so square root of 9m to the 4th is 3m squared. What about the square root of 25m to the 6th? Square root of 25 is 5, yes. And then when it comes time to doing the exponent, remember it's what number plus itself will add to be 6. Because when you're multiplying variables, you add the exponents, right? And so that is the 3 plus 3 is 6. I'm not worrying about the minus sign right now. Hang with me on that one, okay? And that minus sign is outside of the square root. So it's not gonna matter here. Okay? So those are the pieces I need us to think about. Okay? Now, if you look at our format up above, it uses A's and B's, yes? Well, right here, we're thinking this of the form a squared minus b squared. What am I saying is going to be a? Well, we just said this could be what? 3m squared squared, yes? So what is a? A is this square root right here. Okay, so basically the square root of the first term is going to be your a value. The square root of the second term is going to be my b value. Because we can then say minus 5 to the 3rd quantity squared. Okay, so basically I've written that so you can see it's a squared minus b squared. Well, what's the formula for a squared minus b squared when you factor it? Up above it says, which order is it in? Not that it matters, but a plus b times a minus b, yes? Fill it in. What was a?
3m squared.
3m squared plus, what's b?
5m cubed.
5m cubed. Times, now it's a minus b. So a being 3m squared minus 5m cubed.
Oh, we don't have to solve?
No. If you solve it, you're going back to the original answer.
Oh, that's true.
Fair enough? Okay. What we're doing right now, folks, this problem was just a fancy version of x squared minus 25. Have you factored x squared minus 25 before? Yes, you have. Okay. You learned it back in Algebra 1. I've already reviewed it some this year. But it's just that same thing that it factors into two parentheses. The square root of x squared is x. The square root of 25 is 5 plus and minus. That's all we're doing, just with bigger, badder pieces. So basically, look at the square root of the first one, square root of the second one, and put them in. Questions? I don't know. Try not to make this overly difficult, but sometimes it's hard to explain. I just do it. Trying to find ways to explain it. Okay, let's look at B. M to the 8th minus 9n to the 10th. Well, it's kind of the same question as last time. Perfect squares or perfect cubes? What'd you say? Squares. Well, the whole number I see 9. We can take the square root of 9, yes. And remember, when we get to cube roots, it takes 3 of something to multiply to be it. Okay, and then both of those exponents, can I divide them by 2? Yeah, so these are perfect squares. So we're going to have that same format, again, of a squared minus b squared equaling a plus b and a minus b. All I need you to think about. What's the square root of each term? What's the square root of m to the 8th? M to the 4th, yes? Because 4 plus 4 in exponent world is 8. What is that m to the 4th going to be in place of? That's going to be my a because it's the first one. Square root of 9n to the 10th. Yeah, square root of 9 is 3. Square root of n to the 10th is n to the 5th. And this is going to be my b value, yes? Okay. You've taken the square roots, just fill them in. The first square root goes in the front of each parenthesis. So that is what? M to the 4th. Those are my a values. The second square root goes at the end of parentheses. 3n to the 5th. 3n to the 5th. So those go in the second spot. And then we need opposite signs. You've done something like that before, just not with, we factored that before, just not with the big bad pieces. Yes, Emily?
For that, could the answer be like plus or minus, or do we have to?
No, it's not mathematically acceptable to say put the parentheses with a plus or minus in the middle. Now, that does bring to mind, could we flip-flop which parenthesis comes first? Of course. Okay? Okay, what about C?
Cubes.
It's a cube because, well, first of all, I see x to the 3rd. Better do some research on 216. Is it? Sounds right. Okay. 6 times 6 is 36 times another 6. Okay. Which, keep in mind, your calculators can do cube roots. You just have to figure out where. Okay. Any scientific calculator is going to do a cube root. So, this is going to be the difference of cubes. Or, excuse me, not difference of cubes. It's the what? Because there's a plus sign. Don't let me misspeak here. Okay, so with that in mind, let's talk about what our cube roots are. What is the cube root of x cubed? X. And so if this is of the form a cubed plus b cubed, every place I see an a, I'm going to replace it with x. Okay? While we're here, what's the cube root of 216? 6. And that's going to go in place of b. Okay? So the idea here that we are filling in the formula a cubed plus b cubed. And that will be a, I'm just copying down my formula from up above right now. A plus b times a squared minus ab plus b squared. So what I just wrote in purple, that's the formula copied from up above, yes? And just realizing we took the cube root of each of these. This was x quantity cubed, and this was 6 quantity cubed. Okay. Every place I see an A, I'm going to make it an X. Every place I see a B, I'm going to make it a 6. Got it? Let's go. So, and I teach this because here's the deal. This is one going forward, long term, you need to know how to do without having a formula in front of you. So, what I always say, the first parenthesis, the binomial, is the cube roots of the original problem. Well, the cube root of x cubed was x. The cube root of 216 was 6. And you keep the same middle sign. A became x, b became 6, yes? Okay, in your trinomial, the first term is a squared. It's your first cube root, which my first cube root was x. And what do I get when I square x? X squared. Okay, so that is taking, first cube root was x, so now it's x squared. Your middle term is always the opposite sign of the first parenthesis in original problem. So it's a minus. And then it's your 2 cube roots multiplied together. So the x times the 6, or my a times b, which I could write x times 6, but better than x times 6 would be 6x plus b squared. Well, that's always my other cube root, which my other cube root was 6. And when I square it, I'm going to get 36. And that is your factored version for the sum of cubes. Okay? Okay. I don't know if can we get D done? I don't know that we can. I don't know. You guys wanting to try? Are you feeling motivated? Which format is this? What is this? Is it cubes or squares?
Cubes.
These are cubes, okay? And the exponents, you see multiples of 3. So the form I'm eventually going to be filling in is for a cubed minus b cubed, which the formula is a minus b times a squared, opposite sign, plus ab, plus b squared. All I need to know, what are a and b, yes? So let's talk about the cube root, 27, x to the 9th. Well, what's it take 3 of to get 27 when you're multiplying? 3 times 3 is 9, times 3 is 27, yes? So 3x to the, when you're doing a cube root, take your exponent and divide it by 3. What's 9 divided by 3? 3x to the 3rd. Okay, in other words, because I want to be able to say, how do you get x to the 9th in a cube root fashion? Okay, well, it'd be x to the 3rd times x to the 3rd times x to the 3rd. 3 plus 3 plus 3 is 9. I also need, ignore the negative, the cube root of 343 y to the 6th. Cube root of 343. 7. Cube root of y to the 6th. Take 6, divide it by 3, and it's y to the 2nd. What are these pieces I just found? A and B. Fill them in. And I guess we can check that tomorrow. I'm going to go ahead and write it down. You can check it tomorrow with me. Yeah, we'll definitely want to check this tomorrow because of
It's evil? Yes.
it's not evil. It just takes a little bit more.
Pretty close.
Have a good day.
The heck do you? Oh, big English.
I won't be in here. I gotta watch Mo's class. She's in a conference.
Yeah. What about you today? Who sits here? Who sits here? Ashley. Oh, yeah, good to see you. No, not him. Not him. She is, but. What are you doing? Julie. Yeah, yeah.